Your warm-up problems say to copy the problem and solve. Your first problem says, if xy becomes x minus 3, comma, y plus 4, describe the transformation. We notice from the rule that the x shifts to the left 3 units and the y shifts up 4 units. So we would describe the transformation as a shift to the left 3 units, a shift up 4 units. What is a prime if the rule xy forms x plus 1, y is used for a being at the ordered pair 3, 0? Since a is at the ordered pair 3, 0, we're going to have a x of 3 and a y of 0. And so we'll simply plug those into our rule. So x, comma, y forms 3 plus 1, comma, 0. And so now we can just simplify the new numbers. X, comma, y forms 4, 0. So our new ordered pair for a prime would be the values 4, 0. If b is 4, negative 2, forms b prime at 2, 1, describe the translation and write a rule. Well, we can see very clearly that our b value went from 4 to 2, so it has decreased by 2 units. And our y value started at negative 2 and increased to 1, so it increased 3 values. So our transformation rule would start with x, comma, y for b forms b prime at x minus 2. That's how we got from 4 to 2, comma, y plus 3. That's how we got from negative 2 to 1. Now we could certainly check our answer by plugging in our values. If I plug a 4 in for x, we get 4 minus 2. That gave me 2. If I plug a negative 2 in for y, negative 2 plus 3 gives me 1. So we know that that's correct also. To describe the translation, we would say it would shift to the left 2 units and up 3 units. Today we're going to look at for reflections and rotations. Our definition for a reflection is a transformation of a figure that creates a mirror image by flipping the image over a line. And the line that we're going to use most typically in this course is the x or the y axis. There are 2 rules that we need to remember for reflections rotations. The first rule, when reflecting over the x-axis, xy becomes x, comma, negative y. And this reads like xy becomes x, comma, the opposite of y. And I want to briefly describe why that's the case. Remember that if we have a negative value in front of y, and say that I plug a negative 2 in for this term here, then we're going to end up with negative. The value of y is negative 2. And so negative times, 2 negative signs are going to become positive. So we end up with the solution positive 2. That was beginning with the statement if y is equal to negative 2. Now let's assume that y is equal to 2 in the exact same expression, negative y. So we'll plug our value of 2 in, negative, my value of y was 2, and that simplifies to negative 2. So we can see that whatever we started with, when plugged into the given expression, will end up with the resulting opposite. And that's what takes place with a reflection. When we use the rule, we're going to end up with an opposite of y when reflecting over the x-axis. When reflecting over the y-axis, xy becomes negative x comma y. This reads xy becomes the opposite of x comma y. And again, the same process takes place. Whatever value my x was when my original coordinate, it's going to become its opposite. So now we want to look at an example. Reflect triangle ABC over the x-axis. When we reflect, when we reflect triangle ABC over the x-axis, we will notice that it is going to simply flip. So I could fold the paper in half from top to bottom, and the image, if I put it in a really dark ink and then press down on my paper, would layer over, and we'd end up with coordinates up in quadrant 1 that are a mirror reflection of our quadrant 4. And so our reflection would look something like what you see on the screen. Now, another way of thinking of this is my point for value A is 2 units over and 3 units down. It's 3 units away from the x-axis. So my A prime has to be 3 units away from the x-axis in the opposite direction. My C value, or my C ordered pair, is 4 units away from the x-axis. So my C prime would have to be 4 units away in the opposite direction. And so what we noticed very quickly is that whatever my y value is, the prime or the reflected image is going to have the opposite y value, which matches our rule. When we flip over the x-axis, x comma y becomes x comma the opposite of y. What ordered pair represents B prime? Well, we can look real easily at the graph and realize that B prime is going to be 6, 4. Reflect triangle JAI over the y-axis. Well, again, we're going to have an image that will reflect now over the y-axis, but we can look at each individual point, like our point for I, which is 1 unit away from the y-axis. Its reflection should be 1 unit away in the opposite direction. And quickly, I'll go ahead and add the subsequent points, and we end up with a reflection that looks like this. Now we reflected over the y-axis, so we want to recall the rule. The rule would be x comma y forms the opposite of x comma y. And we can see from our image, from our point with the ordered pair for I had a -1, 2 ordered pair. I prime has the opposite of -1, which is +1, comma 2 for an ordered pair. That fits with our rule. And A prime, we can look very quickly at our graph and realize it is at a value of 5, 1. What transformation has occurred in the figure? The transformation that we should have noticed is a reflection over the x-axis. The rule again for a reflection over the x-axis, xy forms x, comma, -y. What transformation has occurred in the figure? Again, we have a reflection over the y-axis. What is the rule that represents this transformation? X, y forms -x, comma, y. All right, I'm going to keep recording now. Next, we want to look at rotations. A rotation is a transformation that turns a figure about a fixed point through a given angle and a given direction. And you'll learn in class that we're going to use a wrap. The wrap goes something like this, but I'm not wrapping. 90 degrees, find the opposite of x, switch the x and the y, the x and the y. 180 degrees, find the opposite of both, leave the x, leave the y, the x and the y. 270 degrees, find the opposite of y, switch the x and the y, the x and the y. 360 degrees, leave it alone, say what? Leave it alone, say what? Leave it alone. And we'll liven it up a little bit more in class. The first rule that we want to look at is a 90-degree clockwise rotation. And so we'll notice that our rule again is x, comma, y forms y, comma, -x. And we could practice with any point just to see how this works. So we're going to use, for example, the x value 2, the y value 1, and do a 90-degree clockwise rotation. Now, if we think of it logically, 2, 1 is in our first quadrant on our graph. That would be upper right-hand corner in position. If I do a 90-degree rotation, that should bring me down to quadrant 4, which is the lower right-hand position on our graph. So let's see if our rule works. 2, 1 forms y, comma, opposite of x. So first I'm going to switch my numbers. And then we're going to take the opposite of whatever that x value was. And so now we can think about our new ordered pair, 1, -2. 1 means I'm moving to the right one from my origin, 0, 0. And -2 means I'm then moving down 2 units. That would in fact end up in quadrant 4. The next rule, when rotating 270 degrees clockwise, xy becomes -y, comma, x. The last rule, when rotating 180 degrees either direction, xy becomes -x, -y. This reads, xy becomes the opposite of x, the opposite of y. So my rotation triangle ABC, 90 degrees counterclockwise about the origin. And do remember that a 90-degree counterclockwise rotation is the same as a 270-degree clockwise rotation, so we're going to use our rule for a 270-degree clockwise rotation. X, comma, y forms -y, comma, x. And in order to do the actual rotation, we can plug any vertice from our image into this rule. So my first ordered pair for the vertice A is 2, -3. And again, we're going to flip them. -3, comma, 2. and take the opposite of y. Y was negative, so now it becomes positive. And we can graph our new ordered pair of 3, 2. So I'm going to show you what that looks like on the screen. Our new ordered pair for A prime is in the position 3, 2. Now, if we apply that rule to each of the vertices, then we should end up with B in the position 4, 6, and C in the position 4, 2. So that we have now successfully done a 90-degree counterclockwise rotation. The next example, rotate JAI 90 degrees clockwise about the origin. What is the rule? The rule is XY becomes Y negative X. And so again, we want to pick any of our ordered pairs. So for I, we have negative 1, 2. Becomes, we're going to flip those. So 2, comma, negative 1. X tells us to take its opposite, so negative 1 will become positive 1. And my new ordered pair for I is going to be 2, positive 1. And so we look at the ordered pairs as they are on the screen. I prime is now in the position 2, positive 1. If you apply the rule to each of the other remaining vertices, you'll get them in the associated locations as you see on the screen. Match your math with what you see on the screen. And you should end up with a 90-degree clockwise rotation around the origin. Our next rotation for triangle GTB is a 180-degree counterclockwise rotation about the origin. And you'll see I've already shown you where the 180-degree rotation will end up with the blue image up on the screen. But we still want to be able to develop our rule and use our rule to find the ordered pairs. So the first thing we need to remember is what is the rule? The rule for a 180-degree rotation, which really doesn't matter if it's clockwise or counterclockwise because 180 degrees either direction sends you to the same spot. But the rule is X, comma, Y forms negative X, comma, negative Y. And so if we're dealing with this particular problem, we can look at any of our ordered pairs. T is at a ordered pair of negative 1, comma, negative 1. It will form the opposite of negative 1 is positive 1. The opposite of negative 1 for my Y value is positive 1. So T prime, A prime, you see what I'm dealing with. Apparently I forgot to change that value, but that's okay. T prime, which I labeled as A prime, will be found at the point 1, 1. We can do the same again for G. G prime is at negative 3. G is at negative 3, negative 1. So it will form the opposite of both. The opposite of negative 3 is 3. The opposite of negative 1 is 1. So my G prime ordered pair should end up at 3, 1. And then since I can't remember which order I brought them in, we'll go ahead and find B. B is at negative 3, negative 5. And again, we run it through our rule. The opposite of negative 3 is 3. The opposite of negative 5 is 5. So my B prime should be at the ordered pair 3, 5. And we see that those show up exactly where they should. Now you also need to be able to determine what transformation has occurred. And here we just simply needed to be able to describe it. So we notice that J is currently in quadrant 2 it has shifted down to quadrant 3, which would be counterclockwise. I'm sorry, that's backwards. We see that J is currently in quadrant 3. The prime, as identified by the red image, is in quadrant 2. So it has, in fact, shifted clockwise 90 degrees. What transformation has occurred in the figure? We see that Q is currently on the y-axis at the bottom half of my graph. It has shifted a complete 180 degrees, so that would be a 180 degree rotation. Now you can practice with your in-class practice and your homework. If you have any questions, I'm more than happy to answer them.